2. Test 1, 2, test.
Videotaped.
Good morning, everyone. Our sincere apologies for lagging behind the time. So the coffee and donuts are ready at the entrance. Our general talk is going to start in 10 minutes. Hello, everyone. I think we can now start. Well, the Chemistry Graduate Student Association would like to take this moment to thank you all for being here today. We truly are grateful for your presence. I would like to thank our official sponsors, Michelin, BWR, Agilent Technologies, and the Graduate Student Council for their generosity and for contributing to the success of this event. I also wish to thank our chemistry department, especially Dr. Zamborini and Dr. Baldwin, for their encouragement and leadership in organizing this initiative. It is now an honor to welcome and introduce our special guest speaker for the 45th Annual Derby Lecture Series, Professor Geraldine Richmond from the University of Oregon. To give you some background on our speaker, Dr. Richmond, she has been at the University of Oregon as a professor since the year 1985, and currently she holds the presidential chair in science. Dr. Richmond is widely recognized for her pioneering work on the molecular behavior of complex surfaces, especially the chemistry of water at the interface, and her research has enhanced our understanding in several fields such as environmental chemistry and energy science. About honors and professional engagements, Dr. Richmond is the recipient of the 2018 Priestley Medal, the premier award presented by the American Chemical Society. She has also received the National Medal of Science and has been elected to the National Academy of Sciences. It is worth noting that from the year 2021 to the year 2025, she has held the position of Undersecretary for Science and Innovation at the US Department of Energy, and her term was renewed through their reappointment by President Trump. In addition to her scientific work, our guest is the founder of the Committee on the Advancement of Women Chemists, simply put, COACH, an organization that champions diversity and inclusion for women in science worldwide. Please join me in extending a warm welcome to our speaker as she begins her general talk.
Thank you. Let's go back a few slides. Somehow we ended up forward. Okay, well, great. Thank you very much for the introduction. And I have to say, looking out at the audience, I don't quite recognize some of you relative to what you looked like last night. So I just want to say, can I say you look better today? How does that make you feel? No, you look okay. You look like a graduate students today and faculty. Anyway, it's a treat to be here. Yesterday was just such a spectacular day, just spectacular in so many ways. The graduate students, the fact that your Department of Chemistry cares so much about the graduate students to allow them to do something like this is really unique. And it does help them as they go on. It's another element of education that goes with the graduate program. So that's really great. So today I'm shifting gears and I'm going to talk as much about climate change and what we need to do in the future to get there. For me, it's been a multi-decade experience. So let me just get started with why that's the case. So in 1998, when I was teaching a science literacy course for kids that really did not want to be taking science, but it was one of the most fun courses I've ever taught. But I showed this plot. And I showed this plot going up to 1990. And that was to show how much the global air temperature had changed up until then. And I told the students that they needed to watch out for this. And there was at that time in the Portland newspaper, there was this article talking about if you ignore it, it's really at your peril. Because this was the beginning of it. And so the recognition that carbon dioxide was a main player in this. And now as we fast forward to now, You can see where we were in 1990, but we're much further with that arrow, but we're much further along now, and the carbon dioxide in the atmosphere continues to grow. Now, in the United States, there's increasingly been awareness of this, but in my decades of travel since that 1998 to different countries in the world, particularly in underdeveloped countries, I saw the ravages of the climate change already. I could see, for example, that the savannas in Africa were drying up. I could see that in India, the temperatures were going up and the rains were becoming unpredictable. In my travels to Vietnam, you could see where people that lived on the coast could no longer live there anymore because the water was starting to rise. Here in the United States at that time, 2005, 2010, many people, not everyone, could afford to buy out of it and could ignore it because we could turn our air conditioners up a little more, turn the water faucets up a little more, or just ignore it but not everyone. We still have disadvantaged communities that were beginning to notice it more. But now we all see it. So when the call came from the Biden White House to join the team working on climate change back 4 years ago, it was an opportunity I just couldn't turn down, even though it meant the difficulties of leaving my graduate students behind and sticking my husband with the house front. But because I truly believe that science and research is the only way out of this, I truly believe that. So what I'm going to do is share with you today the research that's really urgently needed to help us path forward towards a green energy transition. And it may be slowed a bit with this administration, but it's not going to stop. And it's important for us all to take the long view on this because we have to. So let me first describe what my job has been up until the inauguration. So recognizing that there are real serious issues out there, these new technologies that are needed, you can see here, affordable and abundant, reliable, and affordable energy, but also energy is security. So we have to understand that if we have whatever energy systems we put into place, they have to be reliable and they have to be at a point at which we can run them for our national security, not only economic security, but national security, because our grid at any point could be attacked. We also have to address the issue of carbon emissions to mitigate the climate change. And so this is why research provides us an opportunity to feel like we're doing something towards this, and not just feel good, but actually make a difference in people's lives, whether it be in energy resources, whether it be in storage, or in any type of utilization of the energy. So for those of you that aren't used to political org charts, this is this describes sort of the Department of Energy, which is a mission agency, which means that its mission is to address energy, environmental, and nuclear challenges through transformational science. That's the mission of the Department of Energy, and as you'll see, it funds both basic and applied research. So during the Biden administration, the Secretary of Energy was Jennifer Granholm, who was just the most amazing leader I have ever worked for. She was governor of Michigan. You could do a check box of all the great skills of the best leaders around there, and we would check every box for her. Underneath Secretary Granholm was David Turk, who was Deputy Secretary and assisted her. And then there were the three of us that are undersecretaries. And you can see I'm Undersecretary for Science and Innovation, and as I'll show you in a moment, I oversaw all of the research in the Department of Energy, both the basic and applied. It was about $15 billion portfolio. David Crane was an undersecretary that basically worked on getting things out in the field as opposed to the research, and using a lot of the bipartisan infrastructure law money as well as the IRA, Inflation Reduction Act money, billions of dollars out as quickly as possible into communities to help them on energy issues and reduce the carbon dioxide in the atmosphere. The person who had the hardest job was Jill Ruby. And Jill Ruby is an engineer with a master's degree in engineering, but she's in charge of all. So maybe you may not know, but the Department of Energy is responsible for all the nuclear weaponry in the United States. That means that they're the ones that the Department of Energy builds them, and then every year they have to send a letter to the president to say that we have examined all of our nuclear weaponry and it is safe. So in addition to that, Jill also had to meet with all the different countries that have nuclear capabilities and make sure that we stay safe. She said she'd never seen an administration that operated, and she's been around for a long time. She worked at Los Alamos and Sandia National Laboratories, and she said it was the most amazing group of people in the White House working on nuclear safety in this country. She's the one that didn't get much sleep every night because she knew everything. So that put me in the role of being the top scientist at the Department of Energy, which meant that what I supported, my programs, I needed to be able to convince the two people above me who were not scientists but were lawyers. And so I'm certainly glad that I had 20 years of teaching introductory chemistry to help me with that. Okay, so in addition to my research portfolio, we then at the Department of Energy, we have these 17 DOE national laboratories. And Jill was responsible for the nuclear ones, and those would be Los Alamos, Sandia, and Livermore on the West Coast, and the rest were mine. And the rest of them are funded by the Office of Science, which is really fundamental science, and then also the applied sciences, but I'll do more about that. But these DOE laboratories, and you have a couple nearby, certainly with Oak Ridge, but also Savannah River, they are powerhouses of research, but also applied and basic research. And they have these phenomenal computers, exascale computers, faster than anywhere else in the world. And they also, more powerful than anywhere else in the world, but they also have users facilities where any graduate students, postdocs, researchers can come in and use those user facilities, with their X-ray light sources being, I think, the coolest of all. And because these provide X-rays that can get crystal structures, for example, of every pharmaceutical that goes on the market, right? You can't get it anywhere else. And has a lot to do with microelectronics, too. So it's just a phenomenal portfolio of skilled people and workforce. And always interested in postdocs and collaborations with graduate students, but also hiring postdocs. Okay, so let's move over to the science area. So let me explain to you what's in the research that's done at the Department of Energy, and then I'll talk a little bit about where we are right now. And so I want to leave enough time, though, in this, so I may run through these pretty quickly, so that we have time to have a discussion, particularly because what's happening now with regards to funding for research in the United States leaves a lot of uncertainty with, I'm sure, many of you. So in the Office of Science, you can see here, I don't know how well you can read it, but certainly nuclear physics. This is the physics behind everything that we have for not just nuclear weaponry, but also nuclear power plants. At high energy physics, basic energy sciences is the biggest part. The Office of Science has been a budget of about $9 billion. And about $5 billion of that is in basic energy science. That has material science in it, that has chemistry, that has a lot of atmospheric work, although a lot of that's also in biological. Advanced scientific computing, research is there, fusion, isotopes, and so forth. So just funding universities all over the country, graduate students, as well as the national laboratories. So then, on the other side, are taking that basic research, which is what we call TRL levels of like 0, 1, 2, and over to which means they're ready for closer to ready for market, to the applied energy offices, where they take what's there in the fundamental science and they translate that into the applied science. And so all of these were in my portfolio also. Now, nuclear and fusion, the nuclear here is basically nuclear power plants. And getting closer to, we didn't yet have a fusion office in the applied side because I didn't feel fusion was far enough along for it to be there yet, but it's getting close. And you can see here, geothermal, that's enhanced geothermal. So this is going deeper than we've done before in order to produce energy. Batteries and storage, the fundamental side was in the Office of Science versus deployment, critical minerals and materials, hydrogen, transportation, wind, solar, you can see them all there. Now, where that is today, given what we've heard about a cutback with regards to issues related to working on climate change, what I'm getting from my folks in the Department of Energy now is that the main focus will be, we don't know what the focus will be on the Office of Science. We do know there will be a cutback across the board in the Office of Science. And again, a lot of people have been fired or left, but there's still teams there. And on the applied side, nuclear will be strong from the current secretary. Nuclear and fusion will be very strong. Geothermal will be very strong. The grid will be strong. Critical minerals and materials, storage. Carbon management will go more towards drilling and fracking. Hydrogen will be cut back a bit, but it'll still go. And transportation's already commercialized so much that I don't think that'll be hurt so much. Wind and solar, it's going strong too. So keep in mind with all of these, even with the cutbacks, and I have lost so many phenomenal it's sort of like being with my graduate students again, because it was people in their early careers that went into science policy, just incredibly talented, PhDs in science, sort of 20, 30-year-olds. Many of them now are looking for jobs and really struggling, but they put together fantastic work, and I'm sure they'll find a place to go. Because we know that the rest of the world isn't sitting idle with regards to climate change, even if the United States decided to slow. And the competitors may take the lead in this massive rocketing industry. But, even a recent report by the U.S. Information Administration and Bloomberg report predict rising new renewable electricity generation, even in scenarios where the Trump deregulation agenda is successful. Solar capacity is expected to triple by 2035 and wind to double in the next 10 years. And renewables are to be the major key growth area in energy jobs. So and in fact, I think I saw a statistic the other day that said in Texas that the amount of energy generated by solar in Texas is far surpassing even energy that might come more from fossil fuels. We're moving. The other one that I started off in my office was the critical and emerging technologies, and this is one that I'm very proud of, and is continuing. And that's to basically have a front door for anything having to do with quantum and AI and biosecurity. And so there are a lot of different programs in the Department of Energy have programs that could use AI. But when somebody wanted to know, for example, on the grid, what are they doing with AI, this is kind of a front door. This office is a front door to let them, to help navigate where to go elsewhere. But I was in DC earlier this week and met with the group, and they're doing just great. Okay, so what we launched, and what I'm going to talk about now are the Energy Earth Shots. And this gives a roadmap for things that are important in this area. And what the Energy Earth Shots are about is that we've identified 8 areas. 8 areas that if for us to decarbonize the atmosphere and go to more green energy. These are 8 areas that we've got to figure out the basic science for and the applied science for if we're going to make progress. So you won't see solar here because solar we've already made a lot of advances, but you will see 8 other ones. And to also demonstrate global leadership. And I say this because as you're thinking about research and thinking about what you're doing now or in your future, keep these in mind because a lot of the areas that are here also overlap with some of the areas that will continue to be funded. Now, since we announced these, private companies have announced plans to build or expand more than 900 clean energy supply chain factories for solar, wind, batteries, and EVs. So much more. Okay. Here's what they are. And I'm going to go through these, but I want you all to know that you can have my slides. Okay, so I'll be happy to pass my slides on, so it gives you sort of, but also give you the report where you can get it all. Okay, so let's get started then. So the one thing that I'm really proud of that I did at the Department of Energy is when I showed you the basic sciences and the applied sciences, there was a huge impedance mismatch between the two for decades. What I mean by that is they didn't talk to each other at all, okay? And so these Earth shots were an avenue for them to work with one another. And it was amazing to have people that had worked in the Department of Energy for 15 or 20 years in the Office of Science say they never knew somebody in the applied sciences was interested in what they were doing. So it's really great to see that come together, and I think that will continue also. But the Earth shots were the way to do this because they all have a component of basic, applied, and then also deployment. So let's get started. You know, we oftentimes think that research is linear, that you do the basic research, then you send it off to the applied research, and then it'll get deployed, or companies will take it on. But you know it isn't that way, because you get the basic research done, you pass it on to somebody else doing the applied, and something goes wrong. So they got to cycle back. The material broke down, so they've got to cycle back to the basic science to be able to figure out what to do and then round about. And our national labs are really good at that. But the Office of Science is now much better about that too. But we need that cycle going, not just a passing on. So first, long duration storage. This is storage that can hold its juice for 10 hours or longer. And this is to give more grid reliability, as well as for grid reliability with distributed sources. But also, as you know, transportation requires a net generation of electrical energy sources, both hydrogen as well as and the batteries help with that too. So it's the build out of solar and wind are great, but you know, they don't go all the time. So you need to have that batteries. They need to have those batteries there. So being able to build those long duration storage batteries are important. And then we all have toys. We all have toys that need power with them too. But we also need better batteries, because many of you may know that if you have a lithium-ion battery and you recycle it many, many times, it expands, it grows, and so it no longer fits in your device. And so we have to make sure that our batteries are even better, even though they seem to be okay for some of our toys. Okay, so details, a few details on the long duration storage. We need to be able to have new materials. That's a big deal. We need to be able to have materials that can withstand this recycling back and forth. We also need to make sure that they can work in a fairly caustic environment. But we also, for example, need to have batteries that don't require lithium. For example, there's some work going on in the laboratories around the country using sodium, salt, instead of just lithium, but also for hydrogen using it as a storage. So you go to the scientific research, and then you go to the development, and that's where you're really testing to make sure that it's going to work. So you can see here testing, redesign, making sure that whatever was with the basic research, that then you can take it further, because you want to then pass it on to scale up and commercialization. Now, the goal, each of these Earth shots has a goal, and you can see up here in the white, although pretty much shaded out. The goal for the long duration storage is a 90% reduction in the cost of a battery now for something that's 10 hours of duration, and then and have that goal within a decade. And maybe we can turn down the lights a little bit so that we can see that a little better? Can you do that back there? If you can't, it's not a big deal. Not a big deal. We're fine. We're fine. Okay. So that's the long duration storage. There's a whole lot of stuff that needs to be figured out there. And so, for example, the scientific research areas, you can study how the composition and the structure and the membranes and the anodes and the cathodes can be a lot more reliable than they are now with minimal degradation. So, chemical decomposition is a big deal. What causes this expansion is largely phase changes in the materials that are inside, oxidation and corrosion. Lots of good stuff. Lots of good stuff. Okay, now, next, I'm going to fly through these again. Hydrogen. Hydrogen, get it down to $1 for 1 clean kilogram of hydrogen in 1 decade. And what I'm showing here in the circle is that you've got the grid there, you've got carbon capture, you've got nuclear. All of those things have to go on the grid, and hydrogen can then play a big role in that too. So hydrogen can be used as storage, but it can also be used for electrolyzers in order to produce electricity. So hydrogen's a big deal, and we chose 8 hubs across the United States to be hydrogen hubs, and multi-billion-dollar grants to either a state or a multitude of states together. I don't know if Kentucky was in with some of the collaboratives. But some of those will go forward. I learned last week. Some of those will continue to go forward, particularly if they're in red states. But at least some of them will go forward. It's politics at its something. Okay. So with this hydrogen shot, we need new polymers. We need new ability to do electrochemical conversion of the hydrogen, electrolysis better, and also better photoelectrochemistry. And you go over to the development demonstration, reduce the cost, reduce both the electrolyzers and the thermal conversion, demonstrate advanced pathways so that you can get it to a cost that companies will take it on. Because companies don't do much basic research. They do some applied, but you've got to get it to a cost at which they're ready to adopt it because they don't want to take on more risk. And that's what the goal of these Earth shots are, to get everything to the point where companies will take it on and the government no longer has to put any money into it. That said, for the money that was put out in the Biden administration in all these areas, for $1 spent, the private sector put in $6, right? So it's a 1 to 6 multiplier because they saw that this was the future. So that's why I'm optimistic that this is going to keep going. Okay, enhanced geothermal, way down deep, and the drilling, oil companies and drilling companies are good at going down there, but they use it they bring up something very different. And what we're doing, flickering, what we're doing here, the whole point of this is you want to be able to get that heat, you want to be able to drive a turbine that then produces electricity. A little better? Sort of. That's fine, that's fine. So that a little bit better. But here's the deal. So it's really hard. You got to get down there. You got to get down towards the core. You got to get deep. You got to bring the heat up. You got to bring the liquid up there that's overheated up. But you got to have walls that can withstand those hugely high temperatures. We don't have those materials yet, right? We have Forge, which is at Utah, which is one plant that's getting us started. But we need advances in materials so that you can bring whatever the heat or the water up. The other thing is that those materials have to match the soils. So the soils in Utah are going to be different than the soils in the Adirondacks or the soils anywhere else. So this is where geoscience is really important, and also material science to make this work together. I think we're fine. Yeah. I think you guys okay? Can you see the slides okay? Yeah, okay, we're fine. I'm getting just a little too picky. Okay, so there's just a lot going on in this area too, but geothermal is one there's going to be a lot of energy, I think, put into this. A lot of energy, a lot of money put into this also. And here is what the map looks like with regards to where the heat mostly is that you could do for geothermal, mostly on the West Coast, but there's also areas that are on the East Coast. And people now use heat pumps that are thermally driven in houses, certainly in the Northeast. But these are taking the heat that's a lower level, at a higher level than going much deeper. But people often say to me, but does this mean Old Faithful is going to die because we're going to take all that heat? No, it's not. It's not, because it's much, much deeper than that. But this also is a picture of all the different kind of materials you need to do. Okay, this one is for all the chemists out there. And it's a product shot, products, clean fuels and products. And this is really to decarbonize the fuel in the chemical industry through effective sources of carbon by advancing cost-effective technologies that can achieve 85% lower net greenhouse gas emissions by 2035, so 85% reduction in carbon dioxide by 2035. So this is really new technologies, as you can see, to enable low-cost, low-emission feedstocks, whether that be from crops or recycled materials, and also new carbon-efficient conversion technologies. So that's the chemistry side, and then to pilot and demonstrate that at scale, and to take that to where it can be scaled up, so decarbonize the fuels in chemical industry. So this is a big deal, and I think it challenges all of us that are interested in, on the chemistry side of things, how we can contribute and look for ways in which our science can help this. So whether it be SAF for airlines, fuel with biomass gasification, that's going on, but also more powerful liquids that don't give up so much carbon dioxide. Advanced catalysts, right? For those of you doing anything with catalysis, you're in business for just about everything. And also novel reactors and technologies. So a lot of things going on in this area too. But that reminds me, when talking about, particularly about factories, I'll come back to that one in a minute. I have a great story. Okay, so next one is affordable home energy shot. And even though you're never supposed to say, no matter how many children you have, you're never supposed to say, this is my favorite. This is my favorite. Okay, so. And my favorite is because it aims to reduce the upfront cost of upgrading a home by at least 50% while reducing the energy bills by 20% within a decade. So this is everything from insulation to figuring out how you can be smarter with your home in terms of your energy uses. It's heat pumps. There's big tax credit for heat pumps right now, which is still continuing, and as well as insulating your homes. What's really cool, some of the neat things that I've seen with regards to insulation, because there was every year there's on the mall in Washington, D.C., companies come, laboratories come and show off their new kinds of insulation. And one of them that was really neat was they making, from Colorado, beetles have been eating the trees in Colorado for a long time. But it's really upscaled now. So that they're eating them, it's killing the trees, and they're taking that bark from the trees and making it into insulation. They got rid of the bugs, it's okay. But making it into insulation. And most importantly, the way they make it, makes it so it's fire retardant on top of it. So instead of this pink sticky stuff that you see around your houses, to have this kind of insulation is really important. I've also seen where that new kinds of insulation are being developed up in Alaska. So as many of you know, as it gets warmer down here, it's also getting warmer in Alaska and the Arctic. And that means that the permafrost is melting. That means that the houses are sinking. That means also that the water is rising along the coastline. So those that have lived on the coastline, again, have to figure out how to move inland. And so big villages, this is really largely having to do with native villages that are on the coastline, fishing villages. They're going to have to move inland also. So one of the laboratories that's doing some really neat stuff in addition to the insulation, because now the houses, if they're better insulated, they're not going to be melting, they're not going to be also contributing to the melting of the permafrost. So So first of all, a lot of the houses in remote areas of Alaska and remote areas in this country too just have insufficient insulation. So what they've done is they've not only developed better insulation, but they're taking those big storage tanks, it's not tanks, storage boxes that you see coming across, that are on railroads, and also you see the carrying products to the U.S., on the ships and so forth. They're taking those, they're emptying them out, they're building a kitchen and a bathroom in them, okay? And then the rest of the house can be built on it. So they're modular. But then they've got to move it. So what they did was they built skis underneath them so they can just push them up the hill off of the coastal areas and land them in a safe place, adjust everything in the home for that, but then they can level it too by having those skis underneath it. So really cool ideas that really come from the very fundamental research that's done. And there's another time I went to Seattle and I went to a low-income housing project for the elderly in Seattle in downtown. And the DOE had funded to put in heat pumps for the water alone, and also the same thing in the Tenderloin. The people that lived there, that heat pump reduced their energy costs just for the water by 40%. See, so things like that can really make a difference in communities and houses. And so we have to keep that going, because, and in fact for the money that was given out, and hopefully still will go, some of it will at least go out, 60% went to disadvantaged communities that had never seen someone come to them and help them with their houses. That includes native villages here, even in the lower 48, that don't have reliable electricity and don't have water still. So to think of that, and I don't want to see those left behind, but at least we're hoping that they can continue in some form. But smart controls also. So this affordable home energy shot really helping to make high-performance materials, novel materials for energy efficiency, advanced coatings for roofs too, as well as technologies to store the heat for days and weeks and so forth. So a lot of really good stuff there. Okay, the carbon negative shot. I know some of you are working on carbon capture. We put a lot of effort into this, and that's aims to enable the removal of CO2 from the atmosphere and durable storage at meaningful scales, less than $100 per net metric ton of CO2 equivalent in a decade, and that's to be able to store it in old mines or a lot of other places too. And there's a lot to be done there too. It's material science, it's coupling direct capture with other greenhouse gases. Again, you can read those, but I know you can't speed read that fast, so just keep in mind you get these slides. But the whole point of this, I want to reiterate this again, is to get the research to the point where companies can take it on, because that's when it gets adopted, and that's why solar has been adopted, because it got to a cost at which companies can take it on. Industrial heat shot. This has developed cost-competitive decarbonization techniques for big factories that are doing big stuff that may just be run on big fuel systems, as well as to create, I mean, if you go any apartment complex, any large building, any factory that's out there produces a lot of heat, as you see it in the wintertime when you see the heat, what's taken to heat up that building. This is really for the industrial sector, though. This is to, for example, steel making. Steel making is extraordinarily heat intensive, right? Because you got a big furnace, big blast furnace that's making the steel. And there's a plant in Indianapolis, the outskirts of Indianapolis, that I visited that, I can't remember the name of it. It'll come to me. It's huge. It's the biggest factory of steel in the United States and almost the whole world. They have decided to prove that they can make this steel with hydrogen, by burning hydrogen. And so I went to the plant, and sure enough, they got it going. And I went inside the control room for this plant, and they had all the monitors around the wall, you know, that took a picture of what, as best they could, of what it looked like inside the blast furnace, you know, so and figure out what the temperatures and so forth were. And there's only one guy working in there. So I said, wait a minute, everybody go for lunch, or how come you're the only one watching all of this? And he said, well, we integrated AI into all this, so I'm the only one that needs to be here. Which is, I know, some people lost their jobs, but on the other hand, they can be doing other things too. So there's just remarkable changes that we can make if there are some early adopters that will take it on. And then floating offshore wind shot. We have windmills on land. We need to get more out in the ocean. But that means also being able to tether what energy is produced onto the land, and that can be challenging. But again, there's a lot, the turbines, making the turbines so they're recyclable rather than having them only last 10 years and ending up in a junk pile. And there's a lot of cool work going on with regards to these recyclable turbines. Okay, so those are the 8, but we didn't quit there. We also had a whole bunch of, which will continue many of these too, other cross-cutting efforts, and that's in critical and emerging technologies that I talked about. Also, clean energy technology manufacturing, which ties a bit to some of the earth shots. Critical minerals and materials that will continue to be a big deal, particularly to be able to isolate and purify rare earths, as well as lithium replacements. You know, we have no Department of Water in the United States. Isn't that amazing, right? With all the water issues that we have, particularly in the western United States. So there's actually a coalition across the agencies that will probably continue, which talks about the coupling between energy and water, because there, you can understand in hydro, that's an important connection. That will stay I'm sure that will stay also because they're working with hydro. Fusion energy, some people think we'll have a fusion demonstration plan in about 5 years. We'll see, but at least things are moving quickly on fusion. There was the big advancement that was made at Lawrence Livermore National Laboratories a couple years ago, which showed that they could get a net gain with fusion for the first time. But what wasn't noted so much in the press was the fact that when they did this fusion at Lawrence Livermore National Laboratory was more, so you never had to do nuclear underground testing anymore. So it was a different use than for producing energy. It was still an important test. Grid modernization as well as industrial decarb. So as this temperature continues to rise, we're not giving up. So don't give up hope. We're going to continue to work on this. And what gives me hope is that really in just 2 years, America has invested more than $500 billion in clean energy and infrastructure that will be taken forward. The vast majority has been for American businesses and consumers, and as I said, for $1 invested by the government, the private sector has invested $6. So where's the money gone? There you go. There's where the money's gone. More than 80% of clean investments across all technologies have gone to disadvantaged communities. 81% have gone to counties with below average weekly wages. 86% have gone to counties with below average college graduation rates. And as these communities benefit, we all benefit. So all together this year, we projected to add more than 60 gigawatts of clean energy to the grid, more than double the amount we have ever added in a single year. And that's equivalent to 30 Hoover dams. So up and down the battery supply chain, a lot of different battery companies opening up and ready for business. So here's my quote from Secretary Granholm. Our government-enabled private sector-led approach has created homegrown and clean energy economy that is now inevitable. So if you want to follow any of this, there's a great report, Charting the Path, an Energy Earthshots and Initiative report. A lot of what I've talked to you about is in that report. So I'm going to leave this up here, but it's just, I hope it stays on the web long enough. But it really has a lot of good advice for how to go forward. And with that, I'm going to wrap it up and see if you have any questions. Yeah. Okay. Yeah.
A couple of questions. One, thank you for reviewing all of the Earthshots.
Yeah.
So do you think Earthshot will exist in the next 2 years? I'm just curious because the goal is net zero carbon, and the motivation for the current administration is, look other way for the net zero carbon.
Yeah.
I'm just curious on that one, and then also this Office of Clean Energy Demonstrations.
Yes.
What's the fate of that?
I think it's dead. I think it's going away. To be quite honest. Certainly a lot of people are gone now. So with regards to continuing, do your first question again. I got so depressed by OSED. What was your first question again? Oh, is all of this going to continue? Earthshots. Yeah, so the Earthshots are going to be there, but the Earthshots they won't be called Earthshots. Every time an administration comes in, they have to rename stuff. But in that case, there won't be much on carbon capture, and there won't be so much outreach to other communities. But there will be, as I said, fusion, nuclear, hydrothermal, enhanced geothermal, but also hydroelectric. Those will continue, and drill. Those will continue too. But again, we have to keep in mind that we have to take the long view, and we also have to keep in mind that there's a lot of companies out there that truly believe that what they're doing is important. Yeah. So I think, I don't know that I'm the most optimistic person on this, but I think I'm realistically optimistic. So thanks for that question. What more? Okay, I see two in the back. Here first and then behind. Okay.
Yeah, to what extent you pointed out that most of the advancement is due to research. And to what extent is continued research in the United States affected by the political whims of the latest president, of whoever happens to be president.
Yeah, so I think, well, whoever's the president gets to do what they want, but they also have to face Congress. And Congress has to, and we know that that's divided too. That said, if we look historically at the Republicans, they tend to have supported basic research more than the Democrats. Not so much applied, but on the other hand, Democrats have been strong supporters of applied. So of my portfolio, it's you know, kind of like this once in a while. I think that because of the request for budget reductions everywhere, then the research, unfortunately, is going to be cut in a lot of places. Again, that depends on how Congress reacts. But I think, you know, when I was at Los Alamos a couple of weeks ago, and the lab director there made a very good point, and a point that's kind of hard to take, but it's true. And that is when Vanderveer Bush started the National Science Foundation after the war to fund universities to do research, then that was at a time at which companies didn't have the capacity to do this kind of basic research, except for Bell Laboratories, for example. And then as we've gone through time, companies up, you know, till 2000 and beyond, companies have gotten to where they do a bit more research, maybe not as basic as we think about in some of our laboratories, but, and universities have grown to do more research too. So the question is, what kind of research is really needed at for universities to do because the companies aren't going to do it? And so if the argument is made that, well, companies are doing so much of this, then why do we need to have so much research in the United States? Well, I don't buy that. Because not only do the more variety of ideas we have out there, the better the research is going to be. And companies generally have a very narrow view of where they're going to go rather than expansive. But what it also neglects is that the research is the vehicle by which we produce the next generation of scientists, like all of you, right? And you're not going to get that in companies. So I think there has to be a realization that there needs to be some adjustments with regards to size. Universities have grown partly because of indirect costs too. But you know, I'm saying this, and it hurts for me to say this, having just a passionate about what universities give to the world and the students too. Did it have to be done this way? No. It needs to be done thoughtfully. And what I worry is that that the cuts have just not been smart cuts, and the cuts will damage us for a very long time. So that's my personal view. It pains me every day and like I said, I was in Washington just a couple days ago meeting with staffers that are in new jobs or not new jobs, and it's really hard. It's really hard. We're all struggling, but we're going to come back. I mean, I lived through the Reagan days, right? Maybe you did too. I lived through the Reagan cuts, and we came back. So the most important thing to do is just don't let this paralyze us. Just got to keep going. Got to keep going. That was a long answer to your question. I have a guy back there first. Okay.
I have two questions. Thank you so much for your great talk. I have two questions. One, can you comment on the recent, like in a couple of years, there is apparent acceleration of the global warming. There is new data showing that the rate of acceleration is increasing in the last couple of years. So can you comment on this? And second, are you concerned about the brain drain in the U.S., from the U.S., really because of all the policy right now?
In both of those, I say yes. Yes, I'm very concerned about the brain drain. I had to testify in February before the Senate on the issues of national security in our national laboratories, in which the sentiment of the Republicans was that everyone in a national laboratory, no one in a national laboratory can be from a country of concern. I mean, all these things are just going to make it a hard issue for the brain drain. Yes, there's no doubt globally that the Earth is warming. There's no doubt. I'm encouraged by the fact that other countries are stepping up, especially the developed countries, are stepping up their efforts too. And that means that they will be able to produce things for your homes, in appliances and so forth, that will be cheaper than you can get them in the United States. So we lose that market share. So, there needs to be a rebalancing. best I can do. Yeah.
Yeah, I was curious, for those of us who are researchers who work in this space who would love to engage with the Earth shots, can you speak, is there a way for us to be proactive about doing that as opposed to just waiting for a funding opportunity announcement and then reacting once a year?
Well, that's a really good point. That's a really good point. And, you know, I think, look, I think funding in most areas are going to be pretty tight for a while, particularly this coming year. It depends on the budget. That said, if you're working in carbon capture or you're working in materials, I think the carbon capture, there are companies around that you can try to couple with as a partner, for example. But in the materials area, materials are going to be new materials are going to be necessary for fusion. They're going to be necessary for nuclear. I mean, we're supposed to have a 16% rise in the energy needs in the next decade because of data centers, right? You can't get all of that energy increase just by fossil fuels. Can't do it. And the AI centers and so forth. So with carbon capture, they may not need so much attention to it, but the question is, how can you keep things going while looking for another way in which what you're doing can be used? And just keep it going. Does that make any sense? Carbon capture is going to be tough. It's going to be tough. But I think working with the companies is important, too, because there are a lot of them out there that are working in this area. I wish I could be more optimistic, but I know that's one, from what I hear, is the one that's going to get less research at the time. I told someone at Livermore National Laboratory asked me about that, and I said, well, are there ways that you can think, for example, with regards to geothermal, is there something that you can think about with regards to geothermal, particularly as it relates to materials and for carbon dioxide storage or something like that? Anyway. We have to be more creative. Yeah. Any other Debbie Downer kind of questions?
I got a downer one here.
Yeah, okay, great.
Do you expect this 900 plus map to grow over the next few years or actually decline? Will some of these
Wait, did you
where
say?
you had 900 plus new, battery
Yeah.
and different
Oh, they'll keep going.
energy, will that still be
Oh,
growing?
that'll keep
or
going.
are some people going to back out and go
They're
out?
not going to back out on batteries. No, batteries will go, and the long duration storage will be a big deal for a long time. And I think even this administration knows that China has been ahead of us in batteries for a very long time. And we just need to up our game on it. So I think the battery companies see that too. And especially as there's more requests with tariffs to use more from this country. I think batteries is a safe place to be working in, and the companies will continue to grow. I think hydrogen will grow too. There's already a number of companies that have been started on hydrogen. And then the nuclear is an interesting issue because, when I talked about the 16% increase in energy that we're going to have because of these data centers, well, you got places like Google and Microsoft saying, oh, well, we're going to build a small modular nuclear reactor so that it can run our data center, so that it won't take energy, so your electricity costs in your neighborhood won't go up. Okay, where are we on small modular nuclear reactors? How many do we have? Right? So we don't even have a demonstration plant for a small modular reactor, nuclear reactor. We're close. But what that means is that they're going to have to find, and the fossil fuel is not enough to do it. So that's why a lot of these, and battery storage is going to increase. Now, then they'd say, oh, well, we're going to have a fusion. We're going to have a fusion plant. Yeah, well, good luck. We haven't even got any kind of a demonstration project on fusion yet either that works. So there's this view that, even though there's this view that nuclear is going to take off, we also don't have any place to store the nuclear spent fuel yet. So we haven't figured that one out either. So I think a lot of those things are pie in the sky, and when reality hits that you can't do all of this with just fossil fuels, you have to use other, and nuclear's not there yet, and fusion's not there yet. You got to do other stuff. So I think that this, the demand for energy is just going to bring us back to where we were. And when it comes back to carbon dioxide, also the recognition that from companies, and we don't want to have the companies just say it's window dressing, but it can be looked as window dressing, who cares? But even ExxonMobil right now has just hired a bunch of people to work on green energy stuff. So they're investing in it too, as well as carbon capture, Was that a little bit up, a little more? Yeah. Huh.
What
Sure.
what do you say to the people that, like, everyone that shows the global warming trends go back to like 18-something, as your chart did, but people will show going back, tens of thousands of years, the Earth's
I
temperature
know.
cycle dramatically, over, and this is just an inevitable thing. What do you say to those people that,
And then you
make
pull
this
out the
kind of
carbon,
argument?
all I do is pull out the carbon dioxide data, right? I mean, that has not been the case historically, but I'm not a geoscientist. But that carbon dioxide data and the tracking of that, and since the Industrial Revolution, having it go up, there's nothing else that can compare with that data. Yeah, and it's, data, right? You show me data, I'll show you data, okay? We are scientists, right? We are data-driven scientists. We make our decisions based on data. And keep that mantra. We make our decisions based on data, right? And keep that in mind. And you all, I have to finish by saying thank you. Thank you for being here for these 2 lectures and for all these great questions, too. Thank you. And now we'll turn it over to Priscilla Lewis, who is head of the coach program. And Priscilla's been with me for 22 years, and while I was in DC, she ran the coach program for me. She's going to tell you all about the coach program. This is particularly interesting for graduate students because she's going to tell you how to negotiate with your boss. Okay. Yeah. Bosses can now leave. No, just kidding. Okay. Go ahead, Priscilla. All right.
So we can just get the equipment to cooperate.